Good evening, welcome in our quiz classes. Block number 1, Unit 4, History of Cosmology. Four point one Introduction. In the previous unit, we have traced the history of pre-scientific cosmology and gone into some of the important themes of contemporary scientific cosmology. In this unit, we shall primarily focus on the history of scientific cosmology. 4.2 Beginning of science. Cosmology. Revelation in science, as in politics, often go beyond the limited changes that the people who started the revolution had in mind. Let us see some great minds who have contributed to the emergence and growth of scientific cosmology. Nicolaus Copernicus, 1473-1543. In 1543, Nicolaus Copernicus proposed to switch the place of the earth and the sun. He put the sun in the center of the universe and placed the earth in revolution around the sun. The count for the daily motions of the heavens. He said the earth rotating about its own axis. CHP 2011 2.
Good afternoon.
Calculate the positions of planets. Copernicus used elaborate geometrical schemes much like these. Greek and Islamic historians are still trying to decide just what sources contributed to his ideas. Ptolemy's system was reasonably satisfactory in matching the observation. Copernicus did not have new and more accurate observation, demanding the overthrow of the old theory. It was a yearning for greater mathematical harmony that made him seek something different. In Copernicus' opinion, when Ptolemy had violated the principle of uniform circular motion. Furthermore, from Copernicus' heliocentric sun-created theory, several observed phenomena followed automatically rather than needing to adjust as they were in the Ptolemaic theory. Coles 2001. A heliocentric system was counter to long-established belief and seemed unimaginable to many. This is why Copernicus wrote in the preface to his book that he had hesitated long whether I should give to the light these my commentaries written to prove the earth's motion. His friends through had often argued and even importuned me to publish this work. Copernicus hoped that my labors contribute somewhat even to the commonwealth of the church, for not long since the question of correcting the celestial calendar was debated. It was true for centuries. The difficult questions of calculating the dates of future stars had been a main motive of astronomical observation and calculation. CHP 2011 further he admitted to ascribe movement to the earth must indeed seem an absurd performance on my part to those who know that many centuries have come. Consenting to the establishment of the contrary judgment, namely that the earth is placed invariably as the central point in the middle of the universe. Yet this logical consequence of Copernicus' innovations was not immediately realized by Copernicus or by others. It was finally organized by Thomas Digges, an English mathematician and astronomer who translated and paraphrased the key parts of Copernicus' works. He said, to the end such noble English minds might not be altogether defrauded of so noble a part of philosophy. Copernican revelation led to the conclusion that the Earth was no longer unique, it was merely one of many similar objects in the solar system. If the Earth were but the one of many similar planets, other planets might also have similar inhabitations. Close to 2001, the principle of plenitude, which interpreted any unrealized potential in nature as a restrictions of the Creator's power, further encouraged belief in a plurality of force. The conclusion was most dramatically emphasized by Galileo and his new telescopic observation. Galileo 1564 to 1642. Galileo's father wanted him to study medicine and he did so briefly at the University of Pisa, but Galileo preferred mathematics and he studied with private tutors in Pisa and then at home in Florence. Soon he was giving private lessons on mathematics and was later appointed to the vacant mathematics chair at the University of Pisa. Here he is said to have dropped in iron balls from the Leaning Tower as a public challenge. Aristotelian philosophers who said that heavier balls should fall faster. They don't feel Galileo probably never attacked as this legend tell it is true to his spirit, challenging authority, thinking clearly, and relying upon actual observation. Aristotelian professors were certainly not friendly to Galileo, and he soon moved to the University of Padua. Galileo built a telescope and he was the first to use this new instrument of systematically explore the heavens, making astonishing discoveries. For example, he discovered four satellites of Jupiter early in 1610. Later in 1610, Galileo returned to Florence as as mathematician and philosopher to the Grand Duke and chief mathematician of the University of Pisa without obligations to teach. Nothing was so disturbing to old ideas as what Galileo saw when they turned his telescope on the moon. His observations of the moon's surface inspired the revolutionary conclusion that the moon was not a smooth sphere which Aristotelians had maintained. He wrote, the surface of the moon is not smooth, uniform, and precisely spherical, as a great number of philosophers believed it to be, but is uneven, rough, and full of cavities and prominences, being not unlike the face of the earth, revealed by chains of mountains and deep valleys. Aristotle's assumptions that only matter below the sphere of the moon was earthy and imperfect was proved to be wrong. Another similarity disowned between Jupiter and the Earth was furnished by Galileo's discovery of how satellites of Jupiter similar to the Earth's single moon. How would they possibly fit into the system of spheres used by everyone since Plato? Galileo considered the four planets never seen from the creation of the world up to our own time to be his most important discovery. In 1613, in a long unpublished letter, Galileo began arguing that Bible and Compendium were compatible. Aristotelians tried to bring the power of the Church against Galileo, pointing to Bible passages that clearly describe the earth as unmoving. Galileo argued that while the reconciliation of scientific facts with the Bible was a matter for theologians, this should not in, interfere with scientists studying nature. In 1616, the Church ordered Galileo not to hold or defend Compensatianism. In 1624, Pope Urban III, a friend of Galileo, gave him permission to discuss the Compensatian system in a book if he gave the Ptolemaic system equal time. The dialogue concerning the two chief world systems was published in Florence in 1632. After some changes required by the Pope, this is usually considered Galileo's masterpiece. Despite his claims to the contrary, the dialogue represents Galileo's strongest endorsement of the Copernican system over its Ptolemaic counterpart, giving devastating refutations of many central tenets of Aristotelian physics. There was complaints and inquisitions ordered Galileo to appear before it in Rome. He was forced, probably under threat of torture, of acknowledge that he had gone too far in his arguments for Copernicus and to abjure the Copernican heresy. His book was put on the index of forbidden books where it remained until 1835. In 1633, Galileo himself was sentenced to life in prison. The sentence was immediately commuted to permanent house arrest. He spent his remaining years in his villa in the hills of Florence writing another masterpiece not on cosmology but on physics and mechanics. CHP 2011. Till the end, he kept close contact with his friends in the church. Aristotelian cosmology envisions spheres carrying the planets around the Earth, solid crystalline spheres, according to some, which provided the physical structure of the universe. Latin in the 16th century, Tycho Brahe observed comets moving through the solar system. This fact shattered the crystalline spheres. Tycho was still conservative, however, he was reluctant to set the Earth in motion as an alternative to the Copernican universe with all planets circling the Sun in the center. Tycho and his own system of the world in it, other planets circled the Sun while the Sun circled the stationary Earth at the center. From his observation of the 1572 nova and the 1577 comet, Tycho was convinced of the falsity of the Ptolemaic system. In Tycho's system, the Earth is absolutely fixed, so that the daily motions of the fixed stars is ascribed to a daily rotations of the outermost sphere, as in the Ptolemaic system. A similar planetary system was proposed in antiquity by Heraclitus of Pontus ca. 338-310 BCE, who however ascribed to the Earth daily axial rotations. From the standpoint of Hyperion planetary motions as seen from Earth, this system is observationally indistinguishable from the compensation model, yet maintains the fixity of the Earth. That later belief was held by Tycho to the end of his life. A main reason was that he had been unable to detect the annual parallax of the fixed stars predicated by the Co- Copernican model. Despite the unprecedented accuracy of the observation carried out with his giant instruments of Urenberg, Tycho could measure parallax down to 2 minutes of ARC 1/30 of a degree. The failure to parallax for fixed stars implied that they would have to be located hundreds of times farther away than Saturn, the outermost planet known at the time, CHP 2011. Johannes Kepler on 1571 to 1630. Born into an undistinguished and poverty-stricken family, Kepler attended the University of Tübingen, now in Germany, in scholarship studying mathematics and astronomy. He went on to the theological school intending to become a Lutheran minister. Soon he was asked to leave and teach mathematics at a school in Graz, now in Austria. It was here that he imagined his quadratic world model based on platonic solids. The theory was wrong, but it made him famous. After Tycho Brahe moved from Denmark of Prague, Kepler visited him there. There Kepler recognized the value of Tycho's voluminous observation, more accurate than any previous. He inherited both Tycho's data and the favor of the emperor. Following Tycho's death in 1601, studying the data, Kepler found what later became famous as his three laws, along with many other supposed regularities, some correct and others now forgotten. Levi 2000. Kepler believed that God, the Creator, had created an orderly and harmonious world. Kepler was committed to Copernicus' heliocentric system, both for its technical advantages, which made it possible to dispense with some of the complications of the Ptolemy system, and on philosophical grounds, including a symbolic identification of the sun with God at the center of all things. Kepler's colorful life was marred in the end by, among other things, his mother's trial for witchcraft and a periodically nomadic and economically uncertain existence under the stress of wars and political upheaval. CHP 2011. Belief in uniform circular motion had been a fundamental aspect of Western astronomy for 2 millennia. This belief was broken early in the 17th century. Kepler, using Tycho's observational data, showed that the Earth and the other planets all travel around the Sun in elliptical orbits. This was the first of Kepler's three laws. It was published in 1609 in Kepler's book on this new Astronomia Nova. The laws Kepler found for the motions of the planets applied equally to the orbit of the Earth. He had abandoned the ancient distinction between the physics of our Earth, his pair below the Moon, and the celestial physics of the higher realm. Levi 2000, CHP 2011. Aristotelian physics no longer worked in the universe of Copernicus and Kepler. A new explanation of how the planets continue to retrace the same paths forever around the sun remained a central problem of cosmology until Isaac Newton explained how objects move under gravity. He accomplished this by showing how motions in the heavens obey the same laws that determine the movement of bodies on Earth. This led the way of understanding what was increasingly seen as a mechanical universe. 4.3 The Mechanical Universe. The mechanical universe was initiated by Newton and taken up by other scientists Isaac Newton (1642 to 1727). Since his father died before his birth and his mother remarried within 3 years, Newton was left in the care of a grandmother. Difficult early years many have contributed to his difficult personality. As an adult, he graduated from Trinity College, Cambridge, and served there as Lucasian Professor. Later, Newton was Warden of the Mint in London and President of the Royal Society. Newton's remarkable intellectual accomplishments include creations of the calculus, inventions of the reflecting telescope, development of the corpuscular theory of light, and development of the principles of gravity and terrestrial and celestial motion. A Newton worldview came to permit understanding not only to the physical world but also of such intellectual fields as politics and economics, in which people sought simple and universal laws of the type demonstrated by Newton in physics. In astronomy, CSP 2011. The omnipresence of God. Pervaded the Newtonian cosmos, the divine presence operated as an immortal ether that offered not resistance of bodies but could move them through the force of gravitation. Newtonian gravitational theory practically demand a continual miracle to prevent the sun and the fixed stars from being pulled together. Newton envisioned an infinitely large universe in which God had placed the stars at just the right distance so their attractions cancelled as precisely as balancing needles on their points. Another possible solution was to place the fixed stars at such vast distances from one another that they could not attract each other perceptibly. In the few thousand years since the creation
हाँ हाँ पक्का हाँ चलो बाय
the incident of Johnson that the stars were fixed in position was not seriously questioned until 1718, when the English astronomer Edmond Halley reported a remarkable discovery: three bright stars were no longer in the position determined an ancient observation that stars were free to move like normal physical objects. CHP 2011 illustrated the motions of the stars and planets as problems in mechanics governed by the same laws that govern motions of on Earth. He described the force of gravity mathematically. Descartes, Laplace and others critics. The French philosopher René Descartes, on the other hand, had proposed a non-mathematical model, or he suggested that the universe consists of two whirlpools, what he says of cosmic matter. Our solar system would be only one of many such whirlpools. Descartes banned from scientific investigations occult phenomena or causes hidden from the senses, yet celestial matter circulating about the earth, pushing all terrestrial matter toward the earth. Descartes' followers distrusted Newton's alternative on mysterious gravitational force acting at a distance. क्या बोली? हाँ? Can we go in? Descartes' mechanistic cosmology was highly acceptable within the general 17th century conceptions of the world as a mechanistic explanation through where but qualitative descriptions of phenomena mechanistic terms during the course of the 18th century. Vortex theory proved unable to calculate the observed planetary motions. Meanwhile, the real Newtonian theory advanced from one precise quantitative success to another. Whole 2011. The solar system contains many bodies, and the calculations of the orbit of any planet or satellite is not simply a matter of its gravitational attraction to the body around which it orbits. In addition, other bodies have smaller but not negligible effects called perturbations. For example, the Sun alters the Moon's motion around the Earth. Jupiter and Saturn modify the motions of each other about the Sun. Or Swiss mathematician Leonhard Euler had developed the mathematical techniques needed to complete
हेलो हैं प्रेयसी बोलो 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 हेलो यस यस आई कैन हियर
perturbation effects. First, he applied them the Moon, and then in 1748 to Jupiter and Saturn with partial success. CHP 2011 and Euler 2011. Still unexplained were large anomalies in the motions of Jupiter and Saturn and the acceleration of the Moon's orbital speed around the Earth. The French mathematician astronomer Pierre-Simon Laplace resolved this in 1785 and 1787 in this book Mechanique Scales, published in 5 volumes between 1799 and 1805. Laplace summarized his studies of celestial mechanics here he proposed that all physical phenomena in the universe could be reduced to a system of particles exerting attractive and repulsive forces on one another. Laplace's writings were not just for scientists. His 1796 book Expositions du Système du Monde summarized for lay people the general state of knowledge about astronomy and cosmology at the close of the 18th century. In the book, Laplace advanced an idea that became known as Nebular hypothesis he suggested that our solar system and indeed all stars were created from the cooling and condensation of a massive hot rotating nebular gas cooled of particles. The nebular hypothesis strongly influenced scientists in the 19th century as they sought to confirm or challenge it. Elements of the idea remain central to our current understanding of how the solar system was formed. CHP 2011. Writers of the Romantic period in the early 19th century, for example, William Wordsworth in England and Friedrich Schelling in Germany reacted against Newtonian cosmology, convinced that the cosmic order was beyond scientific explanation. They sought to breathe divine like back into what seemed an overtly mechanized and increasingly godless universe. The German philosopher Immanuel Kant argued against the Romantics, insisting that metaphysics could not prove and account for the foundations of physical corporeal nature, and that the issue of the existence of the god was completely divorced from direct sense experience. For him, the Newtonian solar system provided a model for the larger stellar system. Kant reasoned that the same cause which gave the planets their centrifugal force, keeping them in orbits around the sun.
कल कर दे 205 रुपया, ठीक है।
हाँ।
हिसाब मुझे बोलने का तो बोलने का कौन इसके हिसाब
Mechanized and increasingly goodness universe. The German philosopher Immanuel Kant argued against the Romantics, insisting that metaphysics could not provide an account of the fundamental foundations of physical corporeal nature, and that the issue of the existence of God was completely divorced from direct sense experience. For him, the Newtonian solar system provided a model. Hello, good afternoon, Spa. Sorry? Extra service? No, we don't provide extra service. Metaphysics could not provide an account of the foundations of physical corporeal nature, and that the issue of the existence of God was completely divorced from the direct sense experience. For him, the Newtonian solar system provided a model for the larger stellar system. Kant reasoned that the same cause which gave the planets the centrifugal force, keeping them in orbits around the sun, could also have given the stars the power of revolving, and whatever made all the planets orbit in roughly the same plane could have done the same to the stars. Nebulous appearing objects in the heavens become in Kant's mind island universe like. हेलो गुड आफ्टरनून स्पा. यस सर बोलिए. यस सुलिए स्पा. ये भीलेपाले ईस्ट में नियर बाय डोमेस्टिक एयरपोर्ट ऑर्चिड होटल. स्टार्टिंग प्राइस 3800. यस. सॉरी. सर्विस आपको फुल मतलब सर्विस दिया जाएगा लाइक स्टीम शावर वगैरह देंगे और ऑयल मसाजेस. कैसे प्रेशर लेना चाहेंगे आप सर, मीडियम और हार्ड? नो नो वी डोंट प्रोवाइड एक्स्ट्रा सर्विस, सॉरी. छूट दिया इनका. नहीं दूसरा. एक्स्ट्रा सर्विस चाहिए उसको. लाइक कोलसियल सोलर सिस्टम्स. Kant's thoughts about the universe had little observational content. The foundations of his cosmological hypotheses were philosophical and theological observation. First entered cosmology in a major way late in the 18th century thanks to an English amateur astronomer William Herschel. Dorothy 1953. William Herschel and the construction of the heavens. The Newton solar system offered a model for the larger stellar system. The arrangement of the stars might well be similar to that of the planets. Furthermore, the Newtonian system provides by analogy a physical explanation for a disk structure, the same cause which gave the planets their motions and directed their orbits into a plane could also have given the power revolving to the stars and brought their orbits into a plane. CHP 2011. In the late 18th century, observation at least entered stellar cosmology in a major way in the person of the English amateur astronomer William Herschel. Herschel, his discoveries were made possible by large telescopes of his own construction. From his observation, William Herschel reported in 1784 a very remarkable circumstance attending the nebulae and clusters of stars is that they are arranged into strata which seem to run to a great length, and some of the I have already been able to pause so as to guess pretty well at their form and direction. It is probably enough that they may surround the whole apparent sphere of the heavens, not unlike the Milky Way, which undoubtedly is nothing but a stratum of fixed stars. CHP 2011. Herschel's telescopes. हाँ एक्स्ट्रा सर्विस चाहिए था इसको. Herschel's telescopes culminating in 1789 with an Ovid monster 40 feet tall were one of the wonders of the world. These powerful telescopes not only revealed more moon about planets and results some quasars appearing notable into clusters of stars but also enabled Herschel to reach further into space than anyone had done before and to begin to outline the running onto great distances. He concluded that the Milky Way, a luminous band of light circling the heavens, is the appearance of the projection of the stars in the spectrum CHP 2011 and Coles 2001.
अरे हुआ हुआ नहीं हुआ तो मैं 5 बजे खुद में दिखाऊंगा भाई नहीं हुआ तो भी
टिफिन क्या लाई
आज भी लाई हो
और बाहर से लेती हो क्या
दी रुपाली नहीं आने वाली है
In the 1785 paper on the construction of the heavens, Herschel wrote that our Milky Way is a very extensive branching compound conglomerate of many millions of stars. Herschel's drawing shows a cross section through the Milky Way, our galaxy, as determined from his observation in the course of time. Remarkable new observational techniques, photography, and spectroscopy did address cosmological questions, but indecisively in 1835, the prominent French philosophers Auguste Comte remarked that humans would never be able to understand the chemical compositions of stars. He was soon proved wrong because spectroscopy and photography helped bring about a revelation in people's understanding of the cosmos. For the first time, scientists book could investigate with the universe was itna
ऑनलाइन बुक है क्या कोई
cosmology and astronomers
नॉवेल है
क्या नॉवेल
नॉवेल है ऐसी
studies development of cosmology as astronomers were able to record and document not only where the stars were but what they were as well. Amateur astronomers, the professional by definition, were already engaged in well-defined research projects such as mapping stars, made photographs that showed some nebulae were made up of many stars but others remained obdurately nebulous, and nobody was able to decisively show changes in nebulae over time. CHP 2011. Spectroscopy held out a promise of differentiating between nebulae made of any stars and those made of glowing gases, and also determining if nebulae were not rotating. But here also the conclusions were questionable, as indeed was cosmology itself as a scientific endeavor. Advances in cosmology during the 19th century were considerable, but only in the 20th century would cosmology be transformed from speculations based on a minimum of observational evidence and a maximum and philosophical predilections into a respectable observational science. तुम आगे क्यों नहीं बढ़े पढ़े
मैं नीट दे रही थी 12th के बाद 2 साल दी मैंने नीट
हाँ
क्वालिफिकेशन नहीं हुआ था ना, मार्क्स नहीं आए थे अपने 370 पे आके रुक गया था मेरा मार्क्स। फिर उसके बाद से 2 साल मेरा ऐसे ही खराब हो गया क्योंकि एडमिशन नहीं होना था और एडमिशन की फीसेस ना बहुत हाई थी। फिर उसके बाद दिल ही नहीं किया।
होता है। Approaching the beginning of the 20th century, the worldview pioneered by Herschel was vastly.
Good afternoon.
Good afternoon.
Good afternoon.
मैंने बोला नहीं नाइट में मैं बोला मैं शाम को जाएगी नहीं हम लोग यही प्लान
Different from that of Aristotle or even Copernicus, no longer were human beings necessarily at or very near the center of the universe. Called 2001, the Milky Way was now understood to be an optical effect with our solar system immersed in a such larger spectrum of stars of roughly disc-shaped stellar system, possibly other island universes scattered throughout a possibly infinite space. Changing cosmological understanding is manifested in changing social views. Know that we Earthlings were but one of possibly many intelligent inhabitants of a possibly infinite universe. There was less reason to believe that we had been created into the best of all possible worlds, and perhaps more sympathy for discontent with the established social hierarchy.
सुबह 9 बजे से 2 बजे तक 8 लाख चल जाएगा उसको दिन में 12-13 लाख डॉक्टर होना पड़ेगा शाम में 5 पकड़ ले 13 लाख महीने का 13 करोड़ रुपए कमाता तो भी कम हो रहा है
ये कौन अटेंड किया था फिर?
रात में क्या
तो यहाँ पे फॉर्म है ना, फिल करना है इसको।
4.4 from our
तुमको नहीं पता कौन किया है अटेंड?
किया होगा यार।
नहीं, तुम्हारी राइटिंग तो ऐसी है ना, ये है तुम्हारी राइटिंग। कुछ भी नहीं किया।
ये इसका रहेगा, किसका पता है?
मैनेजर की जगह कौन साइन किया हुआ?
मैंने
कौन
नहीं
साइन
किया
किया? तुम नहीं किया?
नहीं बाबा, वो कस्टमर करके गया है साइन यहाँ पे।
रखना है कि
पूछो उससे,
देखो ना, कोई है क्या ये नाम का?
क्या नाम है?
आरसी कुछ है।
राकेश।
राकेश है ना? क्या है उसका डिटेल बताओ। थेरेपिस्ट कौन सा?
थेरेपिस्ट जिया।
थेरेपी
नहीं, थेरेपिस्ट थी रूपाली।
थेरेपी
स्वीडिश
है ना?
हाँ।
रूम नंबर?
डेजी।
टाइम क्या था?
स्वीडिश किसने लिखा है ये?
कॉन्ट्रास्ट करके पेन लेना इधर आओ
7:50
ये देखो, इधर देखो।
रूपाली रिफरिंग का क्या है?
ये पहले देखो ब्लैक लेके करो नहीं और ब्लैक लेके तो ये बाद में कभी नहीं जाएगा ना ज्यादा टाइम लगा अभी है ना स्लीवलेस ग्लव मत सिलो इट्स लाइक द स्लीवलेस अभी चल रहा है ये तो इसका है सुनो इतना स्लीव्स का सिलाने का प्रॉपर इतना या तो इतना
असला इसको डिजाइन जैसा
हाँ कॉलर में दिया ना
ओ माय
4.4 Farmer our galaxy to Iceland universes and more. At the beginning of the 20th century, astronomers were unsure of the size of a galaxy. Generally, they believed it was not much greater than a few months of thousands of light years or oasis across and perhaps considerably less a light year. Nearly 6 trillion miles is the distance traveled in a near moving at the speed of light in a vacuum. Also, observation early in the 20th century made it seem that our solar system was near the center of the galaxy. CHP 2011. Therefore, the English astronomer Arthur Eddington said in 1914, it is believed that the great mass of the stars are arranged in the form of a lens-or bun-shaped system considerably flattened towards one plane. The Sun occupies a fairly central position. Shapely a new model of the universe, the vision of the universe was soon replaced with a revolutionary new conceptions based largely on the observation of the American astronomer Harlow Shapley at the Mount Wilson Observatory. The astronomer and scientific entrepreneur George Leary Hale and founded the observatory on a mountain peak overlooking Los Angeles in 1904, and 4 years later, Master
मैम जल्दी
Angels and 4 years and later Master Instrument builder George Ritchie specific for astronomical photography. तुषार तुषार
कौन
तुषार आया था
तुषार कीजिए
शायद प्रिया पीहू है The first hint of a drastically revised understanding of our galaxy came in 1916, starting in Global Earth cluster, a group of hundreds and thousands of stars safely noticed faint blue stars. If they were similar to bright blue stars near the Sun, they must be about 550,000 light-years away. To explain why they looked so faint, he pushed ahead to establish distances more conclusively using a new and ingenious method of measuring the universe CHP 2011 and COLS 2001.
Ödülü çıkmam, tutmam bunu.
हाँ
Oh,
क्या तू देखना थे बाबा रे मेरा नजर
देख
मत
रही हूँ।
नजर मत लगा तो सुंदर होना है मुझे
तो मेरे को भी सुंदर होना है यार। कहाँ से निकली साबुन किधर से लाया? मेरे लिए भी लेके आओ ना, मैं आपको पैसा देती हूँ।
मानो की गाली
हाँ?
नहीं मानो
कौन लगा था कौन है के लिए?
हाँ
किसका है?
क्या
किसका है?
साबुन
हाँ
है को
हाँ
हाँ
किसका है?
हाँ
किसका है रे?
है किसी का
कितना झूठे रहेंगे ना, बताने रहे। देखो ना, लड़की लोग का ज्यादा सुंदर होना चाहिए ना।
मुझको भी होना है
ग्लोवेरा ना मैं लेके आऊंगी कल, ग्लोवेरा सोप।
ये
बोलो ना मेरे को भी सुंदर होना है, कहाँ से लाए बताने के लिए साबुन।
मैं ला
अरे दी
हाँ
बोलो ना।
देखिए होटो पे क्या लगा लिया काला काला इतना काला लगाया ये बैग किसका है गोभी ये
हाँ?
इसका माया और ये किसका है अंदर में सब कुछ
Shapley built a new understanding of the universe by measuring distance to stars based on oh my god
वैसी कुछ ना कहा आपको उधर की तरफ शाम में ये बात अरे क्या साफ सफाई कर रहे हो इसके लिए तुमने बोला तुम बात ना पॉइंट में आ जाएगा देखो और वैसे ही मेरा बैग का पड़ा
The first hint of a drastically revised understanding of our galaxy came in 1916, studying a globular cluster, a group of hundreds of thousands of stars safely noticed faint blue stars. If they were similar to bright blue stars near the Sun, this must be about 50,000 light-years away. To explain why they look so faint, he pushed ahead to establish distances more conclusively using a new and ingenious method of measuring the universe CHP 2011 and COLS 2001. Shapley built a new understanding of the universe by measuring distances to stars based on properties of a type of variable stars called Cephids, named after the constellation Cepheus in which a typical star was first noticed. They are great stars and thus visible to great distances. Each Cepheid varies in brightness over time. In 1908, the American astronomer Henrietta Leavitt had pointed to a remarkable rules that Cepheids away during routine comparisons of photographs. She discovered variable stars brighter on some photographs and fainter on the photographs taken at different times. Leavitt noticed that the brighter the variable star, the longer its period. Shapley used the period luminosity relation to estimate distances. First, he collected all the available data and Safety starts from his own observations and from other astronomers, including figure out their absolute magnitudes. The only physics he need was the simple rule that brightness decreases with the square of the distance. Then safely grabbed period various absolute magnitude CHP 2011 and COS 2001. Safely made the reasonable assumption that Cepheids in distant globular clusters obey the same physics as nearby Cepheids. He observed the periods of distant cephalids read up their presumed absolute magnitudes from his graph of period various luminosity, compared that absolute magnitude with the observed apparent magnitude. This produced distances to many far away Cepheids and the other globular clusters in which they resided. Some globular clusters did not have Cepheids he could measure, and he used other cruder methods to estimate their distances.
15 दिन मतलब एक तो आधा इधर पड़ा है, आधा खत्म हो गया और एक था आधा हो गया।
Shapley found that the globular clusters are arranged systematically around the galaxy, about as many above the plane of the galaxy as below. The clusters seem to avoid the plane itself, the Milky Way. Shapley wrote that this great mid-galactic region, which is peculiarly rich in all types of stars, planetary nebulae, and open clusters, is unexplainably a region unoccupied by globular clusters. Shapley acknowledged that there was an alternative explanation. Maybe globular clusters were not, as he believed, actually missing from the region, but instead were hidden by clouds of absorbing matter along the spine of the Milky Way. CHP 2011. The dwindling significance of humans and their particular planet and divine further still. Shapley noted a historical progression from belief in a small universe with humankind at its center to a larger universe with the Earth further from the center. The geometry had been transferred from geocentric of heliocentric to a centric. The physiological change was no less. He insisted from homocentric to a centric. Some astronomers had long doubted that the solar system was near the center of the galaxy and that people enjoyed a privileged place in the universe. They felt that the odds, given a random distributions, were made small. Now Shapley gave these philosophical positions scientific basic. Hubble's important discoveries. Shapley galaxy was far larger than any previous estimate. Aside from earlier guesses of an infinite stratum of stars, it might indeed be the entire universe, for Shapley had showed that globular clusters were clearly part of the galaxy, not independent island universes. Other notable concentrations of stars and dust, especially spiral-shaped ones, might still lie outside our galaxy, but if they were similar in size to our now enormous galaxy, they seemed implausibly large. Separate island universes were not impossible, but they seemed less likely now that Shapley had multiplied the size of our galaxy manifold. CHP 2011. Shapley defended his conclusions in the so-called Great Debate before the National Academy of Sciences on 26 April 1920. His major concern was the size of the galaxy. His model of a drastically larger galaxy with the solar system far from its center was largely correct, but there was on less solid ground when he argued that the spiral nebulae, which seemed to be much smaller, were part of our galaxy. His opponent Herbert Curtis argued that the galaxy could be as large as Shapley said, yet still be only one of many island universes. If it happened by chance to be several times larger than the average, ultimately observations would prove Curtis correct. But in 1920, Shapley had the stronger position. CHP 2011 and Coles 2001. The centuries-old debate was resolved won by new scientific evidence.
ठीक है, मेरे को बात नहीं करना आपसे अभी सुबह
Produced using laser telescopes and new observational techniques, including photography and spectroscopy. The key proponent of island universes was Edwin Hubble (1899–1953), who, like Shapley, did his पाउडर लगा लो और अच्छे दिखेंगे.
हाँ?
पाउडर लगा लो.
क्या हुआ? पाउडर लग रहे हैं?
लगा लो.
क्यों?
आपको सुंदर बनना है ना.
ऐसे इतना अच्छा लग रहा है माशाल्लाह.
नजर लगा ही नहीं.
नहीं लग सकता. ये लल्ला काजल उसको देख. शुगर
She is the prettiest one. बहू.
हाँ.
उसको.
क्या? किसका?
हम दोनों.
किसको?
अच्छा.
किसको?
मैं करूँ तू.
ओ नो नो नो.
जल्दी जल्दी ना.
नो.
ऐसा.
ओ नो.
किसको मसाज देना है?
I give him, then she will give me. Last time he asked for that. Let's go.
Shapley did his revolutionary work at the Mount Wilson observation. Writing in his doctoral thesis in 1917, Hubble noted that catalogs already included some 17,000 small faint nebulous objects that could ultimately be resolved into groupings of stars. Perhaps 150,000 were within the reach of existing telescopes, yet he wrote extremely little is known of the nature of new well and no significant classifications has yet been suggested. Not even a precise definition has been formulated. The way Hubble discovered to classify nebulae is described here. After serving in World War I, Hubble joined the Mount Wilson Observatory staff. There he took photographs of nebulae with the new 100-inch reflector, the most powerful telescope in the world. Hubble discovered variable stars in an irregular nebula by now Shapley had left Mount Wilson for the Harvard College Observatory. Hubble wrote to Shapley in 1923 to tell him of the period. Shapley wrote back, "What a powerful instrument the 100-inch is in bringing out those desperately faint nebulae." CHP 2011. Early in 1924, Hubble wrote to Shapley again. This time, Hubble reported, "You will be interested to hear that I have found a Cepheid variable star in the Andromeda Nebula. I have followed the nebula this season as closely as the weather permitted, and in the last 5 months have noted 9 novae and 2 variables. When he found a Cepheid variable, Hubble realized he held the key to distance. As Shapley had used the period luminosity relations for Cepheids to find distances to globular clusters in our galaxy, so Hubble could find the distance to the spiral nebula M13. Hubble found that the distance to M31 comes out something over 300,000 parsecs. This is roughly a million light years and several times more distant than safely estimate of the outer limits of our own galaxy. Hubble continued, "I have a feeling that more Cepheid variables will be found by careful examinations of long exposures." CHP 2011. On regarding Hubble's letter, Shapley remarked to a colleague who happened to be in his office, "Here is the letter that has destroyed my universe." CHP 2011. Shapley admitted that the large number of photographic plates that Hubble had obtained were enough to prove that the stars were genuine variables. By August, Hubble had still more variables to report. Shapley was glad spiral nebulae as the island universe's Hubble discovery of Cepheid variable stars in spiral nebula and the distance determinations confirming that spiral nebulae are independent galaxies were officially announced on New Year's Day 1925 at a meeting of the American Astronomical Society. He followed this preliminary paper by further work over the next 4 years with convincingly convincingly voluminous detail. A good part of Hubble's genius and much of the acceptance these revelatory conclusions commanded were due to lots of hard work. Before the 1920s ended, astronomers understood that the spiral nebulae lie outside our own galaxy in the previous decade. Shapley and multiplied the size of the universe by about 10 times. Hubble multiplied it by another 10, if not more. Hubble's universe was no longer the one all-comprehending galaxy envisioned by Shapley. Henceforth, the universe was understood to to do composed of innumerable galaxies spread out in space further than the largest telescope could see. Hubble next would show that the universe is not static as nearly everyone then believed, but is expanding. What he had made infinite in space, he would make finite in time. CHP 2011. That was the cosmology till the beginning of 20th century. The story of the contemporary cosmology will be taken up in the following units.